philosophers and anthropologists rate speech and memory as distinguishing achievements of man over the other animals. Having shown that Madeline can be taught to recognize and remember certain coded information, her next step up in evolution would logically be the acquisition of speech ability. In this demonstration, Madeline is taught to recognize the spoken word. The speech sound waveforms are separated into frequency components and chronologically scanned by the computer.
0, 0, 0.
For example, the word zero has a characteristic wave pattern.
0.
A series of filter banks separate this complex waveform into 8 distinct frequency bands. These 8 bands are examined in 10 time segments and quantized for 4 different amplitude levels. The speech translator feeds into Madeline the amplitude variations for each frequency band and each time segment so that she will learn the sound of each word. The list of words is entered on the typewriter. The instructor is requested to repeat each word until there is sufficient data to teach the adaptive circuits.
Throw. A. Run. C. Ball.
The processed waveform is then fed into the simulated Madeline until adaptation is completed. Madeline indicates when this is achieved. She now demonstrates that she remembers and recognizes the words she has been taught.
Spot is a dog. See Spot run. Throw the ball to the dog. Idiot. Does anybody speak French?
Un, la, rouge, à, courir, est, lance, regarde, est, à.
The same training procedure is followed to condition Madeline to understand another language.
Rouge. Lance la balle rouge.
Amari wa akai.
Black ist ein Wunder.
French, Japanese, German, or Swahili. It's all the same to Madeline once the sound shape of the words has been memorized. Since adaptive circuits have the distinct capability of being taught rather than programmed, solid-state research at Stanford University has developed a new adaptive component for Adelines. The memory unit is a unique magnetic structure having most of the same attributes of the memistor and capable of very rapid adaptation. Patterns formed on the light panel are conditioned to plus or minus values by pressing the appropriate desired output button. The actual output signal light and meter indicate when the desired output is attained. Adaptation is taking place, although it occurs so rapidly it appears to be instantaneous. Connected to the IBM 1620 computer to provide a high data rate input, the magnetic Adeline sees and remembers 250 patterns per second. In that interval, the computer showed the magnetic Adeline 367 patterns and caused it to adapt on 40 of them. Checking with several patterns demonstrates that the Adeline now recognizes the 12 distinct patterns fed in by the computer. It was not programmed, it was taught this information.